Hello everyone, this is Aditya and today we are going to solve a system of linear equations. So here we have 10 equations and we have 10 variables. So we have to solve for x1, x2 till x10. So let's see how we can solve it, but for that please do like, share, subscribe and please support this video. So now let's start with the solution of this problem. So we can clearly see that there are 10 variables over here and we have 10 equations, right? Okay. Now, of course, I know that first of all, instead of solving this equation, let's solve a simpler version and then we can solve this equation, right? Okay. So let's assume a linear equation in three variables, a system of linear equations actually. Suppose you have x plus y is equal to 1. X plus 2y is suppose 3 and y plus 3z is equal to 2. Let's assume this is the system of linear equations. So over here we have three variables plus we have three equations, right? Correct? Okay. So how are we going to solve this equation? Let me take another chalk too, then I am explaining. So till the time you can just check it. So we have three equations: x plus y plus z is equal to 1, x plus 2y is equal to 3, and y plus 3z is equal to 2, right? Okay. So how are we going to solve it? Either you can solve it directly because it is just three variables. So you can find it using augmented matrix method, in which you find the echelon form. So let me explain it. So we all know that it can be written as ax is equal to b, correct? How? Let me explain it. So first equation can be written as x is equal to 1, correct? And this equation can be written as correct. And third one can be written as like this: 1 times y plus 3 times z is equal to 2, right? So we can write it like this, right? Of course they both are equal. Of course they're same actually, I should say, instead of equivalent, right? So what is matrix A? It is given as the coefficients like this, the coefficients of the second equation, the coefficients of third equation, correct? This is the matrix A. And what is x? X is given as the variable x, y and z, okay? And how is the matrix B given? It is given as 1 3 2. So the moment you multiply A and x, I mean A multiplied by x, not x times A times x, okay? So what is its order? It is 3 comma 3 cross 3 and it is 3 cross 1, right? So of course x times y is not possible, right? Only A times x is possible, right? And what will be the resultant, the order of the resultant matrix? It will be 3 cross 1, okay? So of course it is 3 cross 1, okay? So when you will multiply it, you will get x plus y plus z is equal to 1, x plus 2y plus 0z is equal to 3, 0 times x plus 1 times y plus 3 times z is equal to 2, right? So this is the whole, so it means that this equation is correct, okay? Means it is always correct. It was just an example, okay? And what's next? We will be using the concept of augmented matrix. What is augmented matrix? Let me explain it. You can write it as 1 1 1. This matrix itself 1 2 0 0 1 3, and it is augmented with 1 3 2. Now you will apply elementary row transformations operations to solve it further, and we are going to find pivots over here, right? So let's see, we have got this augmented matrix. Let's say it as M. Now let's solve it. Okay, let me erase this portion, then we'll solve it. Okay, so this is the augmented matrix M, right? And this A matrix and this B matrix. Okay, right. So what we have to do in this problem? Well, we have to bring it in echelon form, right? So let's see how we'll make it to echelon form. So to make it in echelon form, we need to find the pivots. And how do we find it? You can watch my one shot on linear algebra. In that I have covered it. You can check Philosophers Academy linear algebra one shot by Philosophers Academy. You will get the video itself. Okay, or I will give it in description. So let's see how we can find it. What will the answer? So this is it. So this row 1, this row 2, this row 3. Okay. So what I'm going to do is that I will I will transform row 2 as row 2 minus row 1. Okay. This is the operation. There are 3 operations. I'm using one of them. Okay. So this will be 1 1 1 1. Okay. Now 1 minus 1, it will be 0. This will be 0. And 2 minus 1 will be 1. And 0 minus 1 will be negative 1. And 3 minus 1 will be 2. Right? Okay. And this will be as it is 0 1 3. Okay. And of course this will be 2. Now what's next? Now what I'm going to do is that I will write row 3 as row 3 minus row 2. Correct? Okay. So augmented matrix M can be given as 1 0 1 negative 1 2. Correct? Right. Okay. Now 0 minus 0 is simply 0. And 1 minus 1, of course, 0 again. Now 3 minus 1 will be 4. 4. And 2 minus 2, of course, it's 0. Correct? Right? So now we know the property that if Ax is equal to B gives us the solution, then after row transformation, if we get this equation, A prime x is equal to B prime, then this also gives the same result. Okay. So this is actually A prime and this is B prime. Correct. So we have A prime x is equal to B prime. Now just open it. What you will get? You will get 1 1 1 0 1 negative 1 0 0 4 times x y z is equal to 1 2 0. Correct? Okay. Just open it. You will get x plus y plus z is equal to 1 and y minus z is equal to 2 and 4 times z is equal to 0. Correct? So from here you can say that z is equal to 0, y is equal to 2, y is equal to 2, y is equal to 2, and x plus 2 plus 0 is equal to 1. So x is equal to negative 1. So what was the original equation? It was x plus y plus z is equal to 1. So when you substitute y as 2, x as negative 1 and z as 0, you will get this equation satisfied. Okay. This is correct. Now what is the second equation? X plus 2y is equal to 3. Now x is equal to -1. -1 plus 2 times 2 is 4 minus 1, which is equal to 3. So this is also correct. Okay. Now this one, y plus 3z is equal to 2. Now what is y? Y is equal to 2 and z is equal to 0. So this equation is also satisfied. So all the three equations are satisfied. It means that this is the root. X is equal to -1, y is equal to 2 and z is equal to 0. They are the only root, the unique solution of this system of linear equations. Okay. Now how do we know that this is unique? Because rank of A is equal to the rank of matrix B is equal to the number of variables over here, n, right? That is why it has unique solution, right? Okay. And if rank of A is equal to rank of B, but it is not equal to the number of variables, then it has infinite solutions. And if rank of A is not equal to rank of M, rank of M, the augmented matrix. So if rank of A is equal to rank of M is equal to n, then we have a unique solution. And if rank of A is equal to rank of M is not equal to n, then we have infinite solutions. And if rank of A is not equal to rank of M, then in that case we don't have any solution, right? Okay. So now let me erase this and now let's solve this equation. Okay, let me erase this now. So we have this humongous equations. Let's see how we can solve it. So over here A is 1 1 1 1 1 2 3 4 5 6 7 8 9 10 10. Okay. We'll need, I think I should directly write the augmented matrix. That will be better. Okay. Else we will need more space. That's not required. Okay. Okay. So now we have 1 1 negative 1 1 negative 1 1 negative 1 1 negative 1 negative 1. Okay. And corresponding to this we have 55. For this we have -5, and to this we have 2 1 0 0 0 0 0 0 0 0, and corresponding to this we have 4, correct? 4. And similarly we have 0. For x2 we have 3. For x3 we have -1, and then 0 0 0 0 0, correct? Is 3. Okay. Now we have x3 plus x4. x3 x4 is equal to 11. Okay. Now we have x4 minus x5 plus x6. 0 0 0. x4 is 1. Okay. -1 -1 +1 and rest 0 0 is equal to 5. Okay, is equal to 5. I think it will take almost half the board. So now we have this equation. X4 is done. X 2x5 0 0 0 0 2x5 0 0, and it is equal to 9. Okay, so this is equal to 9, right? Now we have this one, x7. I don't know why I've written it in different color. Yeah, so x7, 1 2 3 4 5 6, x7 is 1, x8 is 1, this is also 1, and then 0, this will be 24, correct? Okay, now we have this one, x7 x8, this I have done, x8, x8 is 2, negative 1 1 17, correct? And then we have x1, x9 is equal to 1 1, and then 2, and this is 30. Now let me check I have written all the terms or not. 1 2 3 4 5 6 7 8 9 10. Yeah, 10 terms are there. Okay, now this is a really big matrix, so let's see how we'll solve it. Okay, now we have to make 0 over here. This is the first goal, to find the first pivot. Okay, so what I'm going to do is that I will do row 2 as row 2 minus row 1, correct? Now I'm not going to write it again because of course it will take lots of time. I will make changes directly in this matrix. Okay, so when I will do this is the first step. Okay, or maybe I should write it again so that the original equation remains. Okay, if you want you can skip this part, or maybe I will cut this when I will edit this video. No, I think that will be waste of time only. Okay, so r2 minus this, so this will become 0. Now negative 1 minus 1, it will become negative 2. This will become 0. This will become negative 2, 0, 0, negative 2, 0. This will be negative 2, and this minus this, it will become negative 60. Negative 60, correct? So we have found this equation. Now what's next? We have a 2 over here. So what are we going to do? We have to remove this 2 first of all. So let's see. Second operation which we can do is that R3 we can write as R3 minus 2 times R1. This is the second operation which we can do. So this will become 0 because 2 minus 2 into 1 is 0. Now 1 minus 2, it will be minus 1. Now this will be negative 2. 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 This will be negative 2 again. This will be also negative 2. This will be also negative 2. Negative 2, negative 2, right? Now 4 minus 110. 4 minus 110 is, it will be minus 106. Okay. Now what we are going to do next? Okay. So we have this. So now we have to eliminate this negative 1. So what we can do is that we can write R3 as R3 minus 2 times R2. 2 times R2, right? What we'll get? This will be 0. What is negative 1 minus 2 times R3 minus R2, sorry. So this will be 2, and this will be 2 times negative 1, it will be negative 2, and so it will become 0. Okay, so 2 times this 2 times 0, it will become 0, sorry, it will become negative 4. Now 2 times negative 2, it will become negative 4. Negative 4 minus minus 2, it will become positive, it will become again negative 2. And this will be negative 4, negative 4, and 2 times r3, 2 times this, it will be negative 2 times, so this will be again negative 2 only, this will be negative 4, and this will be negative 2 only, and this will be again negative 4. And now we have 2 times this, that is, so this is negative 152, right? Okay, so now we have to eliminate these zeros over here, right? Correct. So let's see how we can do it. So now we have this one, so we have this and this, so now we have this one. So what we can do over here, fourth, r4 can be written as r4 minus r4 minus 3 by 2 plus 3 by 2 r2, correct? 3 by 2 r2, right? So this will become 0, this will be as it is, 3 by 2, 3 by 2 of negative 1, it will be negative 3, negative 3 plus 0, negative 3 plus 0 will become negative 3 again, this will be 0 only, and this will be again negative 3, it should be in this, and this will be negative 3, correct? And this will be in this sequence, yeah, and this will be again 0, this will be negative 3, this will be 0, and this will be negative 3, correct? And r4 is 3, 3 3 plus 3 by 2, that is 90, minus 90, so it is minus 87, minus 87, correct? We have this one. So now we have this much. Now we have to solve these two equations. So let's see how we will solve it. So we will have r4 will be written as r4 minus 4 times r1, 4 times r4 minus r3, right? This will get, okay. So likewise you have to solve all the terms over here. So I guess you can do this calculation. This is the operations which I will be doing. So instead of wasting much time on calculation, I think I should directly write the augmented matrix, the final augmented matrix which we will get, right? Because you can solve this. I have told the method, right? Like this it will be done, because I think it will take lots of time. Instead of wasting time on that, I have already told the method. The main purpose of the video was to tell you the method how to do it, okay? And as such kind of questions we usually do using codes and all, we don't do it manually, but it was as such for fun, I told. So let me write the augmented matrix now, okay? So after solving this augmented matrix to its echelon form, I got this matrix, and of course the numbers which I've got is like too much humongous. So it was obvious that we would have never done this manually. Okay, we would need calculators for it, of course. So this is the expression. I have not written the B matrix over here because there was no space. But B matrix, in B matrix, this value is only there. Okay. Okay. So we have there's the normal. These are like okay. Okay, but this value, the last one, is like too humongous. So let me tell the value what I've got. 1 quintillion 979 quadrillion, 120 trillion, 929 billion, 996 million, and 800,000. This is the final value for Z. Means not for Z, for the last row. I got this. The last row is this actually. And surprisingly, when you will solve it, since I said that this value and the value of the B matrix for this position, they both are equal. So it means that X, I mean, it is not equal. I guess it was, yeah, it is 10 times this value. So X10 is actually 10. And surprisingly, when you solve all the expressions, all the equations which we have got, you will get x1 is equal to 1. So actually, x1 is equal to 1, x2 is equal to 2, x3 is equal to 3, x4 is equal to 4, x5 is equal to 5, x6 is equal to 6, x7 is equal to 7, x8 is equal to 8, x9 is equal to 9, and x10 is equal to 10. Actually, this is the answer. So, who would have imagined that after getting so big expression, we'll end up getting this simple result? So, this was like very big value. So, this is how you will get the answer, okay? So, of course, you won't do this manually, of course. I haven't also done it manually. I've done it using a calculator. So you will also do it using calculator if you want, and I don't think so that such kind of questions is even required to solve, right? But it was just for fun that if you want to solve, then yes, you can solve these problems also. So this is the answer: x is equal to 1, x2 is equal to 2, and this so and so forth. So we can say xn is equal to n is the answer, where n belongs to natural number and n is less than 11. Okay, like this you can represent the answer. Okay, so I hope you enjoyed this video. If you did, then please do like, share, subscribe, and please support this video. And yeah, I've already made a one shot on linear algebra. You can watch that one shot. It was for BTech and MTech. And I'm currently making a one shot, not one shot, lecture by series on special theory of relativity. So please check it out, right? And I'm making videos on other topics also. So please subscribe this channel for to enhance your knowledge. Okay. So till then, bye bye, take care, and all the best.